Hi, hello, this is your Gopal. So, welcome to Physics Ranguru. Today we are going to discuss remaining part. So, rectangular lamina, triangular lamina, hollow cone, solid cone. So, before going to discuss lecture number 6. So, what is going on? What is going on in lecture number 5 we can discuss. In lecture number 5 we discussed solid sphere. So axis passes through the any COM or any diameter or any center. So what is the axis? I is equal to moment of inertia I is equal to 2mr square by 5. As well as we discuss hollow sphere. So this is the axis of rotation. Axis of rotation passes through the any center, any diameter, any COM. So here axis of rotation I is equal to moment of inertia I is equal to 2mr square by 3. So solid sphere moment of inertia I is equal to 2mr square by 5. Hollow sphere moment of inertia I is equal to 2mr square by 3. So today we can discuss some other. Today we can discuss rectangular lamina, triangular lamina, solid cone, hollow cone. So MOI of moment of inertia of rectangular lamina. Moment of inertia of rectangular lamina of a mass m and length is L, breadth is B along the axis passing through its center or center of mass. So consider a rectangular lamina. First you can consider rectangular lamina. This mass of the rectangular lamina is capital M, mass is capital M, and this length is equal to capital L, length is equal to L, and breadth is equal to B. Axis passes through its center. So this is the axis of rotation or passes through the center or COM. From axis to, we will consider from x distance, from axis to some x distance, I will consider a small element dm. So this is the small element dm. The thickness is dx. Consider dx. So this is total L, length is L means, what about this part? L by 2. And this part is L by 2. So this is length, breadth, this is breadth B means this also breadth B. So here we can consider small element. I will consider, I am drawing here small element. So this breadth of this element is B and this thickness is dx and this mass is what? dm. Small element I will consider, that mass is dm. So here you can write dm is equal to, this is a two-dimensional, so that's why, so sigma dA. So here sigma, so what is the area here? This is breadth into this thickness means B dx. So dm is equal to sigma B dx. So this is a two-dimensional. So sigma is equal to capital M by area. What about area here? Rectangular lamina, length into breadth. So capital M by length into breadth. So I will consider small element, find out moment of inertia di is equal to dmx square. So a moment of inertia di is equal to small moment of inertia di is equal to dmx square. So here you can write total moment of inertia I is equal to integration dmx square. Integration dmx square. Substitute the dm value here. So integration dm value is sigma b dx into x square So here limits minus L by 2 to plus L by 2, minus L by 2 to plus L by 2. So here common is sigma is common and b also constant. So integration. So can I write this one? So minus L by 2 to plus L by 2, this is 2 times of integration 0 to L by 2. 0 to L by 2. So here x square dx. You can write this. So here sigma value is capital M by L into B, capital M by L into B into 2. So we can integrate this one. We will get x cube by 3 from 0 to L by 2. So this b cancel. So we can write 2m by L. So substitute the limits. L cube L by 2 whole cube by 3. So here I is equal to 2m by L. So L cube by 8 into 3. You can write this one L cube by 8 into 3. So 2 1 ja 2 4 ja. So I is equal to here's L, here L1 L cancel. So m L square by 4 3 ja 12. So ml square by 12. This is the moment of inertia of a rectangular lamina. So that is, you can consider the dm along the breadth. In case you can consider dm along the lengthwise, so you will get, so we can consider this is y dash. So y dash I will get I in moment of inertia ml square by 12. In case you can consider along the x axis I x dash mb square by 12. So this is moment of inertia of a rectangular lamina of a mass m and length is L and breadth is B along the axis passing through its center RCOM. Moment of inertia along the y axis ml square by 12, along the x axis mb square by 12. So next you can discuss triangular lamina. Triangular lamina. Triangular lamina. Moment of inertia of a triangular lamina of a mass m and height is h and base is b along the axis passing through its center RCOM. So moment of inertia of a triangular lamina of a mass m, height is h, base is b along the axis passing through its center RCOM. Triangular lamina. So this base is b, base of the triangular lamina is b. So height of the triangular lamina is h, height is h. So I will consider a small element dm along the vertical. So this height I will consider from base to y. So this is y, means this part is, this part is h minus y, h minus y. This thickness is, I will consider dy, and this length I will consider, this small element length I will consider L. So based on symmetry, so this is, I will consider point A, B, C, this one is A, B, C, this part is D, E, A, B, C, D, E. So here similar triangles, triangle ABC and triangle ADE. These two are similar triangle, similar triangles. So here triangle ABC and triangle ABE are similar triangles. So I will consider first a small element dm. This is a small element dm. This thickness is dy. This length is L. So this is a two-dimensional. So that's why you can write. So dm is equal to sigma dA. What about area here? dm is equal to sigma length into breadth. So L dy. So here dm is equal to sigma L dy. So what is sigma is equal to capital M by area. So what is this? Is a triangle. Triangle area is half into base into height. So this going 2 is going up. So here sigma is equal to 2 capital M by base into height. Sigma is equal to 2m by base into height. 0 to h. BC and triangle ADE are similar triangles. So from similar triangle we can write. So this length by this breadth. So L by base, length by base is equal to h minus y by h. So from that you can find out L is equal to h minus y into b by h. So you can find out moment of inertia. Di is equal to dmy square. You can find out the total moment of inertia. You can integrate. So integration di is equal to I. So integration dm y square. So substitute the dm value here. So integration dm. So sigma L value L dy into y square. So here sigma is common and here L value you can substitute here. L is equal to h minus y into b by h. Here y square is there, y square dy. So limits from where to where? 0 to height h, total height. So here limits from 0 to height h. So this is the moment of inertia. You can simplify that. So here I is equal to here b also constant, h also constant. This both are constant. So common that. So here sigma b by h integration 0 to h minus y of y square dy. So substitute the sigma value. Sigma is equal to 2m by breadth into height into breadth here one more h is there, so into h. So this can integrate, you can do this integration, h y cube by 3 minus y cube by 3 from limits 0 to L. So here breadth, this breadth cancel, h into h square. So I is equal to 2m by h square, 2m by h square. So y cube, sorry, here y cube you can get y to the power of 4 by 4. So here you can simplify the L. So L to the power of 4 by 3 minus L to the power of 4 by 4. L to the power of 4 is common, 2m by h. This is limits from 0 to h, limits from 0 to h. So we will get here h to the power of 4, here h to the power of 4. H to the power of 4 is common, by h square into h to the power of 4, 1 by 3 minus 1 by 4. So here h square cancel mean here remaining 2. So 2m h square by do the LCM. LCM is 12, 4 minus 3. So here 2 1 ja, 2 6 ja. So m h square by 6, 4 minus 3 1 by 6, m h square by 6. This is the moment of inertia of a triangular lamina. Of a triangular lamina of a mass is m and the base is b and height is h. So that axis passes through its center or COM. So what is the moment of inertia? I is equal to m h square by 6. I is equal to m h square by 6. Moment of inertia of a square lamina of a mass m and the side is. So moment of inertia of a square lamina of a mass is m and side is a about one of the diagonal. So first you can draw the square. Square of a side is a, square of a side is a, that axis passes through the diagonal, axis passes through the diagonal. So this is like a triangular lamina, this is act as a base. So this is two sides. So this part is here two masses, total mass is m. So this of single mass is small m. So this triangular lamina, what is the moment of inertia? I is equal to, mass is here m by 2, mass is m by 2, m by 2, height is h square by 6. We know triangular lamina moment of inertia I is equal to m h square by 6. So here mass is, this mass is m by 2. So that's why I wrote m by 2, h square by 6. You can find out the h here, h. So this is the h. So this side is a, this side is a, this is a rectangular, this is a Pythagoras theorem. By using Pythagoras theorem, this total length is a root 2a. So this total, this one is what? Total root to 2a. So this is the half part you can get. This is the height becomes a by root 2. So from that here h is equal to a by root 2. So substitute the values. So you can write total MOI. So total moment of inertia you can write 2 times of m by 2 into h square by 6. m by 2 into h square by 6. So this 2 cancel. m h square by 6. m h square by 6. What about h value? Substitute here. So m h square value is a by root 2. a by root 2 whole square by 6. Simplify that. A square, root 2 square means 2, 2 6 are 12. So this is the moment of inertia of a square lamina of a mass m and side is a. So moment of inertia I is equal to ma square by 12. So next you can discuss solid cone. So next you can discuss moment of a solid cone. Moment of inertia of a solid cone of a mass is m, radius is r, and height is h about its axis of symmetry. Suppose you can draw here a solid cone. This radius is, this is a symmetry line. So this radius is r. This total mass is m and height is h. From this base to some height, at some height, that I will consider a small element. So this height I will consider, from cone to this distance I will consider y. So this distance is considered y. So this is a like so here solid cone is equal to solid cone is equal to infinity number of discs. Infinity number of disc. Solid cone is equal to infinite number of discs. So disc COM, disc moment of inertia, I is equal to mr square by 2. Disc moment of inertia mr square by 2. So I will consider a small element that you can cut in straight. This is a small element. This thickness is dm and this thickness is dy. I will consider thickness is dy. So this area is pi r square. So this is a this is a 3-dimensional. That's why dm is equal to rho dv. So this is area of a disc pi r square. This thickness is dy. So you can write in dv. So dm is equal to rho pi r square dy. So this is the dm value, rho pi r square dy. Here can two triangles. So this radius I will consider small r. So here two triangles are there. Suppose this one is point A, B, C, D, E. So here two triangles are there, A, B, C. Otherwise you can write here A, B. Same triangle A, B, C and triangle A, D, E are similar triangles. From that you can write the small r by capital R is equal to this y by total h. From that you can write r is equal to y r by h. So here moment of inertia of a disc di is equal to dm r square by 2. I want total moment of inertia. These are infinite number of discs. I is equal to integration dm r square by 2. Substitute the dm value. So I is equal to integration dm is equal to rho pi r square dy, rho pi r square dy. Here 1 by 2 is there, 1 by 2 common. So dm is equal to rho pi r square dy by 2 into r square. Into r square. So I is equal to, so rho pi by 2 r into r to the power of 4 integration r to the power of 4 dy. m, so here you can write this one, 3m by pi r square h. So in place of rho, 3m by pi r square h into pi by 2. So here limits 0 to h. So substitute the r value. So y to the power of 4 r to the power of 4 by h to the power of 4 dy. So here pi cancel. So in moment of inertia I is equal to 3m by 2r square h. So h also common here, h to the power of, here one h is there, h to the power of 4 is there, that is h to the power of 5 integration 0 to h, and r to the power of 4 also common, here r to the power of 4. So remaining y to the power of 4 dy. So I is equal to, here r to the power of r square r to the power of 4 cancel means remaining 2, 3m r square by h to the power of 2h to the power of 5. So substitute the limits, this y to the power of 4 integration y to the power of 5 by 5 from 0 to h. Substitute the limits. So I is equal to 3m r square by 2h to the power of 5 into h to the power of 5 by 5. So h to the power of 5, h to the power of 5 cancel. I is equal to 3m r square by 10. So this is the moment of inertia of a solid cone. So moment of inertia of a solid cone about its axis of a symmetry. So I will consider a cone. So I will consider a small element dm. So this is the moment of inertia I is equal to 3m r square by 10. Moment of inertia of a hollow cone of a mass is m, radius is r, and lateral length is what, L. So next, moment of inertia of a hollow cone of a mass m, radius is r, and this lateral inertia of a hollow cone of a mass m, radius is r, and length is L about its axis of a symmetry. So you will consider moment hollow cone. This radius is, this is the symmetry. This radius is what, r. This mass is capital M. So I will consider a small element. So dy. Small element of a mass is dm. This radius is what, r. So here hollow cone is equal to hollow cone is equal to infinite number of rings. So ring moment of inertia I is equal to mr square. So I will consider a ring. So this is the small element dm. This thickness of this small element is dy, and this is what, 2 pi r. So the circumference of a ring is equal to 2 pi r. So here dm, small element dm is equal to sigma dA. So sigma dA value is equal to 2 pi r dy. 2 pi r dy. So here you can write sigma is equal to total mass by area. So m by, What about area of the hollow cone? Hollow cone is pi RL. So this is the lateral distance pi RL. So here symmetry, this is A B C triangle and this one is ABCDE. So here ABC and ADE, these are two similar triangles. So here triangle ABC and triangle ADE are similar triangle. So from that you can write small r by capital R is equal to, so this length I will consider total L is L and this length I will consider Y. So Y by L. I want small r is equal to YR by L. So here moment of inertia of a ring DI is equal to dmr square, mr square. So like that similarly m small r square. I want total moment of inertia of a hollow cone. So integration dmr square. So substitute the dm value here. Dm is equal to sigma 2 pi r dy into r square. So common sigma 2 pi r into r to the power of 4 integration r to the power of r into r square r to the power of 3 dy. So substitute the values. So pi value, sigma value is m by capital M by pi RL into 2 pi. So integration for limits from 0 to L. Substitute the r value, y to the power of 3 r to the power of 3 by L to the power of 3 dy. So here pi cancel. So remaining terms right here. So I is equal to 2m by r L common and here r cube also common. L cube and r cube is common. So here remaining is RL into r cube by L cube integration y to the power of 3 dy. So this is limits from 0 to L. So here r cancel means here r to the power of 2. So here L cube L to the power of 4. So I is equal to 2m r square by L to the power of 4. So integration of y to the power of 3 y to the power of 4 by 4 from 0 to L. Substitute the limits now here. I is equal to 2m r square by L to the power of 4 into L to the power of 4 by 4. So this L to the power of 4 L to the power of 4 is cancelled. So I is equal to 2 here 2 1 ja 2 2 ja cancel. I is equal to m r square by 2. So this is the moment of inertia of a hollow cone. Moment of inertia of a hollow cone I is equal to m r square by 2. So please all of you, so like, share, subscribe my videos. So all of you bye, take care, have a nice day. Thank you.